Here we are now down in the wood shop. You can see I was working on a cabinet the other day, so it's a little messy down here. But you can also see that I have the tape measure laid out for our measuring. I also have here our single sheet of paper that I'm going to pause really quick and fold into a plane. So here I have our paper airplane done. So step number 1 of our procedure, pick a plane, we're good. Now we're going to run 3 trials for this plane. I'm going to go ahead and just kind of fast forward, but I'm going to kind of show you throwing one of the plane styles here, because what we have to be careful with is there's going to be a lot of things that would factor into this. For example, if I point the plane up too high, that's really going to affect the data. If I point it low, if I stand right here at the starting line versus back here, like all of those things are going to affect data. Actually, I think I just heard my furnace kick on. So I have like a vent up in the ceiling there. That airflow is going to affect how my plane flies. Some of you might be wondering, why am I choosing to do this, inside my wood shop instead of outside? So one, you can see outside here, it started raining, it started snowing, the wind is blowing. All of those things are bad for our experiment because the only thing I should end up changing is the staples. So we need to be very, very careful about that. So what I'm going to do is I'm going to line up at my tape measure. I'm going to take, and I'm going to kind of look at how my arm is, look at the angle of the plane, and I'm going to try and throw at the same power. You can also see here that my woodchuck has a ton of different stuff. I have stuff off the side, I have lights. Like, I need to avoid those things because if it hits any of those, that is going to be a mistrial. So now what I need to do is throw in this plane, because I need to be as consistent as possible. I'm going to take this plane, I'm going to throw it nice and light, and I can kind of see and go measure now where the plane landed. So I'm going to pause and do that, and I'll actually do that a couple more times. I measured that, and before I actually do that, I should make a prediction. I'm going to say the one with staples is going to go first. So I'm going to say that the modified one is going to go the furthest. And I actually measured this first one and it flew, and normally I would do this in metric systems, so in centimeters. Unfortunately, my tape measure doesn't have that. So this plane flew 16 feet, 11 inches. If you want to do your own experiment, you can. If you just want to use my data, you're welcome to. So now what I have to do is I'm going to line up and I'm going to try and keep everything the same, right? I want to line up. I want to make sure my plane is at the same angle. I want to make sure I throw my arm the same way. I want to make sure I'm standing in the same spot. I want to control as many variables as possible. So I'm going to just do this 2 more times, write down the data for you. There you go. You can see the data, and you can see that's not consistent. If I had a 100% perfect, consistent, only one thing changing, only one independent variable like I tried, that would mean that all of my data would literally have been the exact same. The plane would have landed in the exact same spot. Because the plane landed in different areas, flew different distances, I didn't hold something consistent. Realistically, that's part of an experiment. I can't get everything perfect, but we need to try and control it. So I would say overall, this data is pretty consistent. But it does mean that aside from just, it means that we had things in there that changed that we didn't want to. Maybe I threw a different power, maybe my angle wasn't perfect, maybe there's a draft in the house, maybe I stood at a different starting spot. Something was different. So now what I'm going to do is I'm going to make my change. Again, the only change that I want is I said I was going to add staples. So now I'm going to go through and I'm just going to staple the crap out of this paper airplane because that's what I said my change was. Sometimes what happens is students are actually tempted to take and make a different plane that folds similarly. But keep in mind, that would actually be a variable. Now I'd be using a different sheet of paper, which means I'm actually changing more than just the staples. As soon as I grab a different sheet of paper, this sheet of paper might weigh differently. I might not make the folds the exact same way as I did on this one. So I actually want to take, and to make sure the only thing that I'm changing on this plane is adding staples, I need to actually use the exact same plane. Now I'm going to do the same thing. I'm going to line up. I'm going to try and keep every single other thing constant. So I'm going to line up, same spot, get my arm in the same position, same angle, and I'm going to try and throw with the same amount of power, and I'm going to go measure this distance, and I'm going to do this 3 times. Now I actually got an average really, really close. I got about 16 feet, 9 inches, somewhere in there. So you'll notice I had a change in my distances. One was 17 feet 2 inches, 17 feet 11 inches, and then 15 feet 6 inches. not very good data. I decided to roll with it, but odds are I threw something incorrectly there. It came up quite a bit shorter than the others. So anyway, then I would like you to do the analysis questions on your own. So, why did we do 3 trials? Why don't we only do it once? Were you correct in your prediction for which plane would go furthest? It's okay to be wrong. Actually, looking at my data, technically the staples actually wound up shorter. It was 1 inch on an average, so I could probably honestly make the argument that staples didn't really do anything. That's fine. That's part of the experiment. I need to go with what my data shows me. And then you always want to talk about your reliability. Do you think your independent variable, do we think that adding staples to that plane really made a difference based on our data? Was our data consistent? If I come up and I look at our unmodified plane, I'd say that's pretty close. And there's actually calculations you can use to determine reliability. We won't do them in this class. If I look at my modified plane, that data is a lot more inconsistent because we had a 2-foot gap distance in here. That's pretty significant. So I would say that data wasn't as consistent. And then this is one of the most important things. What are things you could have kept constant but didn't? Honestly, if I were to say any question in this lab is most important, it's probably this one. Because this goes back to what we were talking about. In any lab, I only want to change one thing. The only thing I should ever change in a lab is my independent variable. And in this case, that was our staples. So what are some things that we did change on accident? That really goes back to what I've been talking about this whole time. Especially for all of these, something was different. Otherwise, the data would literally been the same. The plane would have literally landed in the same spot. So for all of these, I must have thrown with a little bit different power. I must have had it at a different angle. I may have not started in the exact same spot. A draft may have came in. So that's why humans use things like machines, right? Maybe we invent a paper airplane throwing machine. So it keeps at the same height, it starts in the same spot, it pushes it the same way. But that's really kind of the focus of this unit, is making sure we're thinking scientifically. We're thinking, how can I create as good of an experiment as possible? So make sure that you're going back and you're really truly understanding, what is an independent variable? What's a dependent variable? What is a constant? These other terminologies. Can you write a good hypothesis? Hypothesis, it's okay to be wrong. In fact, some of the best science comes from when hypotheses are wrong. Do you understand what a control group is? And then do you understand what a mistrial is? And can you identify some different errors in your lab, such as what this last question is asking? So that is the purpose of the paper airplane activity. I hope you were able to do your own. If you couldn't, you're welcome to just use my data and answer these questions. All right, thanks for learning with me.